Welcome to solving radical equations. To solve, the first thing you need to do, and I know this is homework, I use it as my notes, and I'll write the notes off to the side when I do each problem. So your first goal is to isolate the radical. So you want to get that radical by itself. So isolate the radical, the whole radical expression. So what's causing it from being isolated is that positive 17, that plus 17. So I got to subtract 17. You have to do this first. So you get the radical by itself. And now you undo the radical. So step 2 is undo the index. So this is a square root. So we need a square. You can never move anything inside the radical until the radical sign is gone. So we need to, square and square root are gone, dropping the square root, and 3 squared is 9. Now we'll just have a quick little equation from Algebra 1. Actually, this is from 8th grade. So you get your like terms together. 3 minus 3 is 0. 2x, negative 2x comes down, equals 6. Divide by negative 2, divide by negative 2, and we get x equals negative 3. Cool, we got it solved. Now we need to substitute back into the original equation. This is not to check your work. This is part of the actual problem. It's called extraneous solutions. Extraneous solutions are solutions that mathematically work out. Like we already worked out that x is going to equal negative 3. But it's not a guarantee with radicals that it's going to work. So we're going to check here. By checking, all you need to do is substitute your answer, in this case negative 3, back into the original equation. We are not solving here, we're just simplifying. So I am solely concentrating on this left side of the equal sign and simplifying it down and hoping that it equals 20. So I'm only going to be working on the left side, and I'm going to be doing order of operations. So order of operations, you're going to treat radicals like they're parentheses. So you got to multiply inside the parentheses first. That's order of operations. Then we have a subtraction. So we have negative 2 times negative 3 is positive 6. So that's going to be 3 plus 6 still equal 20. 3 plus 6 is 9. Square root of 9 is 3. And this 3 plus 17, does that equal 20? Yeah, it does. So therefore, x equals 3 is the solution to this problem. All right. Let's take a look at a problem like number 4. So here I have the radical. It's a cube root. I need to isolate it. To isolate it, I need to move to negative 7. That's being added. So that means that I am going to have to add or subtract. That's all that really means. So it's a negative 7, so I have to add 7 to the right side. (16x plus 8), and that's going to equal 6. And now I have to undo the radical. So this index is cube root. So I got to cube both sides. So it's 16x plus 8, and 6 cubed is, I believe, 216. And I'm going to solve this problem just like I did in 8th grade. Well, for me, it was actually freshman year. 208 divided by 16. I'm going to have to do some quick math on this. Didn't realize I was going to be doing this. Oh no, my Desmo's slow. 160, 48. That's going to be 13, I believe. 208 divided by 16 is 13. Should just trust my brain. Now let's check this. We got to check to see if it's an extraneous solution or is it an actual solution. So to check, we're going to go back to the original equation and just substitute in our answers for x. 16 times 13 plus 8 equals negative 1. So I have negative 7. 16 times 13 is 208, just like what we just did. Plus 8 equals negative 1. 208 plus 8 is 216. Cube root of 216 is 6. Negative 7 plus 6 is negative 1. Check. So you see I did not solve. I was not solving anywhere. I was just simplifying the left side down to a number and hoping that it equals the right side, and it does. So therefore, it is an actual solution, not an extraneous solution. All right, let's take a look at number 5. It's all about isolating a radical. So I'm just going to look on the left side. That radical is already isolated. You just have to isolate one radical. It's not about both of them. Sometimes that's not possible. You just isolate one. Get it by itself. It already on the left side is out by itself. I'm going to undo the index. That's a square root, so I'm going to square. And I got to square the right side also. My square root and square, that's going to drop the square root, which opens up the 3x minus 29. Square root and square drops the square root, which opens up to 41 minus 2x. And now I can solve by getting my like terms together. I'm going to add 2x to the left side, and I'm going to add 29 to the right. And I have 5x equals 70. Divide by 5. I get x equals 14. No. Yeah, 14. So now I got to check this. So I have square root of 3 times 14 minus 29 equals the square root of 41 minus 2 times 14. And I'm going to simplify the left side first. So 3 times 14 is 42. 42 minus 29 is 13. That's as far as I want to go there. And on the right side, I have 41 minus 28. 41 minus 28 is 13. And the square root of 13 does equal the square root of 13. Cool. All right, let's take a look at the back. All right, sometimes, well, it's still the same exact rules. So we have the square root isolated. It's already isolated. So then I'm going to undo the radical. Square. And there's a binomial squared on the right side. Left side will cancel out, which is awesome. And a binomial squared, typically we're going to be, or this is what it means is x plus 4 times x plus 4. So we have x times x is x squared, x times 4 is 4x, x times 4 is 4x, and 4 times 4 is 16. We have 4x, so now we're going to get our like terms together. It's always adding, so we have x squared in the top left, 4x plus 4x, and our like terms is 8x, and then plus 16. Now my concentration is I have a quadratic. When anytime I see a quadratic term, this means like it's my biggest term, biggest exponent, I need to move all the terms to one side to see what I'm dealing with. So minus 6x, minus 6x, I'm going to subtract 15, and I'm going to make it equal 0 to see, do I still have the quadratic or don't I? And I do. Now in class we've been working on when a is 1. You can solve this by the quadratic formula, so you got your a is 1, your b is 2, and your c is 1. Quadratic formula works, it's just going to be slow. When your a is 1, there's a quick way to factor. It's what two numbers multiply to c that add up to b. So what two numbers multiply to 1 that adds to 2? Well, that's just 1 and 1. So let's use those. And what I mean by using them is we're going to use them as factors. Those are your second terms of your factor. The first term, the only way you're going to get x squared is by multiplying x times x. And now we set each factor equal to 0 because that has to equal 0. And then with multiplication, when you multiply by something that's equal to 0, well, it equals 0 then. Well, each one's going to equal negative 1. And so therefore, that is our answer, but we have to check it. So we got to check it first. Let's hope it works. So substituting back into the original problem, 6 times negative 1 plus 15 is going to equal negative 1 plus 4. So 6 times negative 1 is negative 6 plus 15 is 9. And the square root of 9 is 3. On the right side I have negative 1 plus 4, that's 3. That's good, 3 equals 3. All right, let's get to a different problem. So number 9. For this one, I need to isolate the radical. What's preventing it from being isolated is this negative x. I gotta add x and add x. Square root of 31 minus 3x, and that's gonna equal, I'm gonna usually put my x terms first, so that's a positive x, and then it's subtract 9. So I'm switching these two around. Then I need to undo the radical, since it's now isolated, so square and square. Now we're very close to what we just did on number 7. I'm going to have square root and square, going to simplify their inverse operations. X minus 9 squared means x minus 9, x minus 9. X times x is x squared. X times negative 9 is negative 9x. X times negative 9 is negative 9x. Negative 9 times negative 9 is 81. I have, in the top left, I have x squared. My two like terms. Remember, we're adding. So negative 9x plus negative 9x is a negative 18x, and then plus 81. I see a quadratic term. And so I move all my terms to one side, get all my like terms together. So I have add 3x. And then I can also subtract 31 to move all my terms to one side to make the equation equal 0. And that plus 50. Now I'm going to do what two numbers multiply to C, 50, that add up to B, because A is 1. And that is negative 5 and negative 10. And after I'm done with this, I'll show you a Desmos trick on how to find negative 10, negative 5, and negative 10. So what I'm going to do is I'm going to break that trinomial up, that quadratic, up into two binomials. I have x squared. To get x squared, you have x and x. We're going to set each term equal to 0. Add 5, you get x equals 5. Add 10, you get x equals 10. We need to check both of those back into the original problem. So our check, and hopefully one of these is extraneous. So I'm going to check negative or positive 5. So positive 5 plus 31 minus 3 times positive 5 equals negative 9. So simplify the left side. I have 3 times 5 inside, negative 5 on the outside, 31 minus 15. 31 minus 15 is 16. Square root of 16 is 4. Negative 5 plus 4 is negative 1. And negative 1 does not equal negative 9. Did I do that right? Looks like it. So that is extraneous. So x equals 5 is extraneous. Now let's check 10. So we got to do a quick check on 10. So I have negative 10 plus square root of 31 minus 3 times 10 equals negative 9. So negative 10 on the outside. 31 minus 30 is 1. Square root of 1 is 1. Negative 10 plus 1 is negative 9. That checks out. So therefore, x equals 10 is our only solution. 5 would be extraneous, so we just cross it out. That's all you need to do. All right, every problem here should be very similar to this. Majority of the problems you encounter are one that I covered. Thanks for watching. Try a little